genes to make new copies of the enzyme. So genetic repression and induction are control elements for metabolism. And then you can control existing enzymes. They're already out there floating around in the cell. You can control their activity either by a post-translational covalent modification, that is like throwing a phosphate on them, or by allosteric mechanisms. What biological signals does metabolism respond to? There's two general kinds. One is energy needs. So a lot of pathways are activated or inhibited on the basis of the energy status of the cell. And some pathways are regulated not by necessarily the needs of that cell per se, but by hormonal signals that coordinate activity across the whole organism. So some cells store energy for the rest of the body, like fat cells or liver with its stored glycogen. Other kinds of tissues don't store any energy. They're going to, like something like a kidney cell or a lung cell or brain cell, it's going to regulate pathways just based on its energy status. If it's got a lot of fuel molecules, it will have a lot of energy. It can do biosynthetic work if necessary. If it's low in energy, it's going to shut down its biosynthetic pathways and stimulate the catabolic ones. It's going to be looking within itself, in other words, judging its own needs and acting accordingly. Other tissues or food depots, in a sense, that are storage places that have to recognize more than just their own needs. Like, so a fat cell's metabolism is controlled not so much by how much energy it needs or has at the moment. There is that. But it's all overridden by hormonal stuff. So maybe the fat cell has plenty of energy and doesn't need to break down fats for itself, but it still can be, that control can be overridden by a hormonal signal that comes to the fat cell and says, start breaking down fat like crazy. Somebody else, like this muscle cell over there, needs a lot